Once logged into PVSketch Mega, there's a few ways we can start a project. We can enter an address or GPS coordinates. This will load a standard map for your site. We can also upload directly a KML or KMZ file that additionally has site boundaries already in it. We can see here our overall site boundary in blue and any obstructions in that KMZ file that we used in orange. In the bottom left-hand corner, we can see our total area and rackable area, which is our blue boundary area, minus any orange obstructions. If we want to add obstructions, or if we uploaded a standard map from an address or coordinates and want to draw our site plan, we can use a number of drawing tools in the top left-hand corner. In this example, I'll simply use a rectangle tool to add in one more obstruction here. We can see that once I added that obstruction, my rackable area and utilized space changed automatically. On the right-hand side, we have our project name and address, our currency preferences. Additionally, we can also note if we have grid power limitations. So if you have transmission limitations for your site, you can input that here. Listed below, we have all of our different ground mounts and obstructions. And so if we want to add a height to any of these objects, we can. For instance, obstruction 4, the object I just drew, I can add a height. Once we're happy with our site plan, we can move on to our slope analysis. In the top right-hand corner of our site window, there's a button that says Get Topography. Select this button to import Google Elevation point cloud data. In the center panel here, we can see a 3D rendering of our site plan. As you hover over any of the triangles, it will give you specific information for that parcel of land: north, south, east, west slope, as well as latitude, longitude coordinates. You'll notice gray areas in this topography. These are areas that are outside of our slope limitations. We can see on the right-hand side here, we have a number of slope limitations that you're able to define based on either manufacturer preferences that you're aware of or personal experience. For instance, if I lower my slope limitations, there'll be more unusable space. If I increase my slope limitation, we can see more of our space becomes usable. Once I'm happy with my topography and my slope limitations, I can update my drawing on the left-hand side. Any unusable space will be transferred into keep out obstruction areas in our site plan. We can also see our rackable area, and percent utilized space has been automatically updated as well. In the Energy tab, we want to specify our production model as well as our equipment. PVSketch Mega automatically generates a weather file for you using MediaNorm or NREL weather files depending on your site location. You can also upload your own weather file if you have your own. For modules, we have a generic option you're welcome to use. We also have a manufacturer-specific database that has extensive make and models for specific module types. Thirdly, you can also directly upload a pan file if you have that as well. If you're choosing to use a bifacial model, you can also input bifacial production values as well. In the Inverter tab, We similarly have a generic inverter option as well as an extensive database of manufacturer-specific options. And finally, you can also upload an OND file. In our final tab in losses, we have a number of losses we can input for our production model. These are all defaults for the production model Cassis. This is a production model built by Canadian Solar, and its outputs are extremely similar to that of PVSketch. In the racking tab, we can now define our different racking options. You can see in the top, you can add multiple tabs, so we can either create a fixed tilt or a single axis tracker racking option. In this tracker configuration, I'm going to define my GCR, azimuth, and skew. These can either be singular values, or we can provide a range for the tool to optimize later. Similarly, instead of using GCR, we can also design with pitch in mind instead. Moving down to racking specifications, we do have manufacturer-specific options, both Array Technologies and Nextracker, but you can also custom define any tracker using our user-defined option. Here we'll define our module string length as well as how many rows we want in our tracker. We'll also define the row and column gap between individual modules and any additional motor gap. Down here at the bottom, we can also define our partial trackers. Because we have a string length of 27 and a row of 1, the smallest partial we can define is a 27 by 1 tracker. By increasing the number of strings we want in each tracker, we can add additional partial and full tracker sizes. For reference, the tool also shows you how many total modules are in each tracker configuration. Finally, define the number of peers you'd like in your largest tracker size. To add an additional racking configuration, click at the top to add another tab. In this option, I'll add a fixed tilt configuration. Again, we have GCR, azimuth, and tilt. In this option, we again are defining our table by string length and row quantity, as well as row and column gap. There's no input for motor gap, and again at the bottom we can specify our partial racks. Moving on to optimization, there's a few different things we can optimize for. We can optimize our system based on system size, both AC and DC, system production, as well as LCOE. If we select system size, either AC or DC to optimize, we'll put in our optimized value here. If we're optimizing for system production, we'll put in our optimized value here. If we're optimizing for LCOE, instead of inputting that value, we'll want to fill out the CapEx and OpEx costs at the bottom. These can be filled out as well for other optimization types, however, they're necessary to run optimization for LCOE. In both CapEx and OpEx, we can see our costs are broke down into easy cost per watts, or in OpEx case, cost per kilowatt per year. Once you've chosen your optimization target and input all of the required information, select the button that says Run Optimization. This could take a few minutes depending on how wide your optimization ranges were or how many racking configurations you chose to include. In the Results tab, we'll see all of our different possible layouts. First, in this graph, Each dot represents a different possible layout. Our y-axis is our LCOE, or our optimization target, and then our two horizontal axes are GCR and DCAC ratio. When you hover over a dot, you can see project details for that specific project, and if you select it, it will highlight the corresponding design on the below project list. This is a list of every single possible layout for your site, and this list can be sorted based on any of these inputs. So there's GCR, module quantity, production, AC/DC system size, LCOE, etc. You'll also notice a input called rank. So the tool looks at your inputs, and based on your specifications, it thinks the project ranked number 1 is going to fit those needs best. Of course, you can sort this list based on any of these inputs and look through them accordingly. Once you find the project you're interested in, you can select it and view the design. Not to worry though, you can come back to this list at any time and view more than one design choice. Additionally, once you select your project, there's a few other outputs here. We can download our hourly production report, a CSV of our bill of materials, and our PVCAD download. All of these downloads we'll see in our later downloads tab as well. Here we can see in Design tab our finished layout. If we zoom in, we can see our partial trackers placed around our different obstructions. And at the bottom, we can see our annual production, system size, and total number of modules. In our Downloads tab, we can download a JPEG of our design. We can download a sales drawing, and we can also download a bill of materials and hourly production output in CSV format. Here's our production output directly from Cassis. We can see our timestamps as well as our production values here to the right-hand side. In our bill of materials, not only do we see our module quantities and our inverter quantities, we also have costs and a racking bill of materials. PVSketch Mega breaks down your layout into tracker types and quantities, so full versus partial, exterior versus interior, and gives you a specific number of each tracker type. Additionally, based on the CapEx and OpEx costs that were input, it gives you total cost for each of those units and total system cost as well. Finally, we can export a KML file and open that in Google Earth if we'd like to see our layout there as well. Finally, we can export our drawing and layout into the CAD space. There's an option to download a standard DWG to your computer, and this will just download a CAD file that has standard poly shapes for trackers and site plan for you to continue designing. However, if you're using PVSketch Mega, we have a smart export that you can use here as well. Copy this link and paste it directly into PVCAD to render your entire project scaled, geolocated, and equipment specific directly into PVSketch Mega to continue the design process.